Good morning, students. Good morning, math enthusiasts. In our previous discussions, we have tackled some simple and complex applications of solutions to right triangles. This time, we will discuss some word problems involving course and bearing. Before we start with those mentioned applications, we shall discuss some definitions. The direction or course to a point is stated as the number of degrees east or west of north or south. Much of this definition was taken from www.mathsteacher.com.au. In this figure, for example, the direction of P is 45 degrees from north to east, or 45 degrees northeast. This is the notation of that direction. The direction of Q is 25 degrees from north to west, or 25 degrees northwest. This is the notation. The direction of R is 30 degrees from south to west, or 30 degrees southwest. And this is the notation of the direction of R. The direction of S is 70 degrees from south to east, or 70 degrees southeast. And this is the notation of this direction. Bearings are also angles used in navigation. They are based on moving clockwise from due north. A bearing is the angle in degrees measured clockwise from north. These definitions are taken from www.bbc.co.uk. Recall the quadrantal angles. The quadrantal angles are 90 degrees, 180 degrees, 270 degrees, and 360 degrees. But if you look at this figure, 90 degrees is at a different location. Now recall in the Cartesian coordinate system that the initial side of an angle is located or fixed at the positive x-axis, and its terminal side is that one that rotates counterclockwise. This time, in the concept of bearing, the initial side is located or fixed at the north line, and it is in the positive y-axis. The terminal side is that side that rotates clockwise and not counterclockwise. Say, from north to east to south to west and back to the north. One cycle of the unit circle is 360 degrees. And that is also the same here. From north to east to south to west and back to north, one cycle is 360 degrees. So that this becomes a 0 degree, 90 degrees, 180 degrees, 270 degrees, to 360 degrees. So in this figure, the bearing of point P is 45 degrees, meaning coming from the north to this point, which is half of 90, is 45 degrees. The bearing of point S is 180 degrees. So coming from the north to point S, so we start from the north to 90 degrees, then to 110 degrees. The bearing of point R is 212 degrees. So we start from the north to 90 degrees, to 180 degrees, then to 212 degrees. The bearing of point Q is 335 degrees. So coming from the north to 90 degrees, 180 degrees, to 270 degrees, to 335 degrees. So please remember this concept in answering word problems involving bearings. Let us now start with the examples. Example number 1 was taken from www.revisionmaths.com. The problem is stated this way. A, B, and C are three ships. The bearing of A from B is 45 degrees. The bearing of C from A is 135 degrees. If AB is 8 kilometers and AC is 6 kilometers, what is the bearing of B from C? Following our usual steps, we now start with our illustration while reading the problem part by part. A, B, and C are three ships. Given this sentence, we cannot draw yet. We just put in mind that we expect 3 points in our illustration. The bearing of A from B is 45 degrees. Now, we locate one point, which we label as B, and draw the horizontal and the vertical lines of the x and y axis of the north, south, west, and east directions. Recall that in bearing, the initial side is fixed at the positive y-axis of the Cartesian axis, or the north line. Now, start rotating the terminal side clockwise. We now estimate that 45 degrees is between 0 and 90 degrees, somewhere here. So we now start drawing a line from the origin of the axis towards a particular point of estimate, and we label it as A. The bearing of C from A is 135 degrees. On that second particular point A that we have estimated, we draw again the axis, horizontal and the vertical axis, and start rotating the terminal side clockwise from the initial side, which is the north line, in such a way that we estimate 135 degrees. 135 degrees is more than 90 but less than 180 degrees. So 135 degrees is between 90 degrees and 180 degrees. So we now draw a line from the origin of the axis to a third particular point, which we label as C. If AB is 8 kilometers and AC is 6 kilometers, so in that case, we label the segments AB as 8 kilometer and the segment AC as 6 kilometers. We may adjust the lengths of the segments to conform with the given distances. So in this case, 6 kilometers is shorter than the 8 kilometers. So we're okay with our illustration. What is the bearing of B from C? We now connect a line from B to C or from C to B. When we say bearing of B from C, it means that the angle to be found is at point C. At point C, we draw again the axis, horizontal, and the vertical axis to inform us that the angle or bearing that we are looking for is more than 180 degrees. So from the north line, clockwise 90, 180, so it's more than 180 degrees. Notice now that we have formed a triangle. But the challenge here is to prove that the triangle is a right triangle. To do this, we improve our illustration. Look at the purple rectangle. We go back again to our knowledge in geometry about the alternate interior angles of a parallelogram or rectangle. So if this angle is 45 degrees, then this angle is also 45 degrees. Now we proceed to the other part of the angle here, which is this part. A straight angle measures 180 degrees. and this angle is 135 degrees. So how do we get this angle? Correct. We subtract 180 minus 135, or subtract 135 degrees from 180 degrees. So 180 minus 135 is equal to 45. So the measure of this part of the angle is 45 degrees. So if we add up 45 degrees and 45 degrees, the sum is 90 degrees, which is a right angle. So now we have shown that this triangle is a right triangle. And this means further that we can use the definitions of the trigonometric functions and the Pythagorean theorem, if necessary, in our solution. To find the bearing that we are looking for, we need to find some values first. Look at the yellow rectangle. Again, the alternate interior angles created by the diagonal of the rectangle as the transversal are congruent. So, again, if this angle is 45 degrees, then this angle must also be 45 degrees. Now, we need to find angle Y degree, this one. Observe that angle, Y degree, is the interior angle of the right triangle. Observe further that we were given two legs of the right triangle in the problem. So we can proceed to solving for angle Y. Using these two given legs or sides, these two sides are the opposite and the adjacent sides of angle Y degrees. So this means that we are going to use the tangent function. So, tangent Y degrees is equal to the opposite side, 8, divided by the adjacent side, 6. After pressing Shift Tan, 8 fraction key 6 equals degree minute second key, Y degree is equal to 53 degrees 7 minutes and 48.37 seconds, or 53.13 degrees. Thus, Y degree is equal to Y degree is equal to 53 degrees 7 minutes 48.37 seconds. Recall that one rotation of the unit circle is 360 degrees. So if we subtract 45 degrees and 53 degrees 7 minutes 48.37 seconds from 360 degrees, then we can find the value of the angle X degree. We now press our scientific calculator with this format: 360 degrees minus 53 degree key, 7 degree key, 48.37 degree key minus 45 equals degree key. The difference that you will see from your calculator is 261 degrees 52 minutes 11.63 seconds, which is equivalent to 261.87 degrees. We have now obtained the value that the problem is looking for. Therefore, the bearing of B from C is 261 degrees 52 minutes and 11.63 seconds, or 261.87 degrees. By the way, I use two notations in giving the values of angles because some books use the notation of degree in decimal form only instead of the degree minute second notation. Example number 2 was taken from www.brilliant.org. Here is the problem. A private plane flies for 1.3 hours at 110 miles per hour on a bearing of 40 degrees. Then it turns and continues another 1.5 hours at the same speed, but on a bearing of 130 degrees. At the end of this time, how far is the plane from its starting point? Illustration. A private plane flies for 1.3 hours at 110 miles per hour on a bearing of 40 degrees. We create a point and label it as P for plane. You can use any variable or letter you would like to use. Create the axis, horizontal, and the vertical, and from the north line, rotate the terminal side and estimate 40 degrees. Extend the terminal side as a line pointing to a particular point of estimate. We label that point as Q. Again, you can label it with the variable you prefer. We label line segment PQ with 1.3 hours and 110 mph. Then, it turns and continues another 1.5 hours at the same speed, but on a bearing of 130 degrees. This time, we draw the axis again, horizontal and the vertical, at point Q, and from the north line, we rotate the terminal side until we reach the estimate of 130 degrees, which is between, but not halfway, of 90 degrees and 180 degrees. We extend the line of the terminal side to a point of estimate onward and label it as R. We label the length of the line segment QR with 1.5 hours, 110 mph. At the end of this time, how far is the plane from its starting point? We now connect a line from point P to R and label it as D for distance. We have formed a right triangle, but we have to make sure that the triangle formed is a right triangle so that we can use the definitions of the trigonometric functions or the Pythagorean theorem in our solutions. So, we improve our illustration. Look at the purple rectangle. Just like in our previous example, if this angle is 40 degrees, then this angle is also 40 degrees. Now for the other part of the angle, and just like in our previous example, we subtract 130 degrees from 180 degrees, the measure of the straight angle, so that we have 50 degrees. So, if we add up 40 and 50 degrees, then we have a sum of 90 degrees, which is a right angle. So, triangle PQR is a right triangle. And we can now apply any of the definitions of the trigonometric functions because the triangle formed is a right triangle. To solve for D, we need the values of the two legs of the right triangle. To do this, you need to recall that distance is equal to rate times time. So, d sub 1, this one, distance 1, is equal to the rate 110 miles per hour times the time, 1.3 hours. So if you multiply this, the product is 143 miles. So the distance PQ is 143 miles. Now for this distance, 110 miles per hour, the rate, times the time, 1.5 hours, then the product is 165 miles. Therefore, the distance of QR is 165 miles. So, we now have the values of the legs of the right triangle. 143 miles, and 165 miles. Observe that D is the hypotenuse of the right triangle. And the two legs of the triangle were already obtained. Thus, we can use the Pythagorean theorem to find the value of D. By substitution, D squared is equal to the square of 143 plus the square of 165. Transposing the exponent 2 to the right side, then we have D equal to the square root of the quantity of 143 squared plus 165 squared. Simplifying, we have D equal to 11 square root of 394, and after using our calculator, D is equal to 218.3437657. Therefore, the plane is approximately 218.34 miles away from its starting point. So the starting point is here, and this is now the location of the plane. So the distance is 218.34 miles. As a recap, in your illustration of the problem, make sure that a right triangle is formed. This right triangle becomes your basis in selecting the appropriate trigonometric function to use in order to solve for the required unknown value in this problem. Making sure that the triangle formed is a right triangle is challenging in word problems involving course and bearing. There might be more complicated illustrations. It is challenging to do operations of angles involving course and bearing. Efficiency in arithmetic is a key. And now, our discussion has approached its end. Thank you very much. Remember, math is easy to learn when one learns with enthusiasm. Bye!